We are doing 2.6a, and it deals with graphing parabolas. So, actually, let's start over here. So if I had y equaled x minus 3 squared plus 2, what is that going to look like? It's right 3 from there because the x's are backwards, and then up 2. And then this is a normal parabola, which goes over 1, up 1, over 1, up 1, and then over 2, up 4, over 2, up 4. What if I had like a negative 3 out front? What is that going to do? So it still starts here, but instead of over 1, down 1, it's going to be over 1, down 3, over 1, down 3. And then instead of over 2, down 2, it's going to be over 2, down 6. Over 2, down 6. No, not 6. 12. Sorry, I was timing it by 2. So normally it's over 2, down 4, but it would be over 2, down 12, and the parabola would look like that. Okay? Well, what if I had, oh, sorry, no, that'll work. We could factor that and find its roots. So that would be x minus 5 and x minus 1. So x is equal to 5 and x is equal to 1. Okay? So we know where it hits the x-axis. But where is the vertex? Well, I know the parabola is going to look like this. And that's a 1. And that's a 5. Where would that point be? How would you figure that out? Well, you need to go halfway between 1 and 5. What is halfway between 1 and 5? 3. So 1 plus 5 is 6, and 6 divided by 2 is 3. So this is the center line. So I just need to know, where does that graph occur at x equals 3? So I just plug 3 in there, and I get 9 minus 18 plus 5. That would be negative 4. So this point right here, called the vertex, is 3, negative 4. That's one way to do it. Okay, the other way is to complete the square. So I'm going to isolate this x squared minus 6x. I'm going to leave a space, and I've just bumped that 5 over a little bit. And you guys completed the square last year. What number do we put inside there? Half of negative 6. So negative 3. But what is negative 3 times negative 3? Positive 9. So when I create this, I need to put a 9 here, and that's the only way for that quadratic to factor into x minus 3 squared. But I just added 9 pounds to one side of the equation. So the equation is now unbalanced. So I have two options to fix that. If I put too much weight on the right side, how do I fix it? I could put the equivalent amount on the left side and it would balance, but this is a graphing equation, so I want this to be by itself. So if I add 9 pounds to the right side, what's the other way to fix it so that it remains balanced? Take 9 pounds off of the same side. All right, so this becomes negative 4. And there's my graphing equation. right 3, down 4, and then I could do over 1, up 1, over 1, up 1. And I get that. Okay, let's do another one. Let's do okay, I need to find the vertex and graph. So I bump this out of the way. Leave a space. Now I complete the square. What goes in the factor? -5. And then I square it, which means this was plus 25. But now the equation is unbalanced, so I have to undo that by subtracting 25. And I get this. So where is that graph? Oh. So it's going to be right 5 and down 49. It would look something like that. Does that make sense? Okay. So it does get a little bit harder than that. Oh, I need to refresh this. All right, so this first one, rewrite a quadratic to find the vertex of the graph. So this is the same basic idea, but now there's a leading coefficient. So y equals -2x squared plus 20x minus 53. So I need to bump that out of the way. Y equals -2x squared plus 20x, leave a space, minus 53. But there's one extra step here because completing the square with a -2 out front is really, really, really tough. So we're not going to do it. We're just going to factor that out. So I'm going to take a -2 out of each of those. So whatever number is there, if it's not a 1, you need to factor it out. So y equals -2 times, if I take the -2 out, what's left? X squared minus 10x, leave a space, minus 53. Does everybody follow so far? Move the constant out of the way, factor out the leading coefficient, and notice I didn't try to take a -2 out of the 53. Even if it was, say, 54, I don't want to take the -2 out of the 53. Okay? So now I complete the square. What would go inside the factor? X minus 5 minus 53. So if this is x minus 5, what goes here? 25. And if I just add 25 pounds right there, what do I need to do to offset that? Here's the tricky part. It's not really 25. It's a -50. Why? Yeah. This portion of the equation is hiding underneath a -2. So by placing a 25 inside the parentheses, I've really subtracted 50 pounds because it's -2 times 25. So instead of adding 25 to the right side, I actually removed 50 pounds. How do I fix that? I add 50 outside the parentheses. So this turns into -3. Okay. Now, Where is the vertex? 5, -3. And it's not asking us to graph, but what would the graph look like? So we go out to 5, -3. Normally it's over 1, down 1. But we're going to double that. So over 1, down 2. And then normally it's over 2, down 4. But we're going to go down 8. So over 2, down 8. Over 2, down 8. And that would be our parabola. Okay, so this is called standard form. Standard form is really good to find the roots. It's really good at finding the roots. All you have to do is factor it or use the quadratic formula. Okay. This is called vertex form, and vertex form is really easy to find the vertex. They're the same equation, they've just been dressed in different outfits. Okay? So you need to be able to go back and forth between vertex form and standard form. And to go from standard form to vertex form, you just complete the square. How would I turn this back into that? I would just do the multiplication. I would raise this to the second power, x minus 5 times x minus 5, and then I'd multiply in the -2 and subtract 3, and that would get me back to standard form. Okay, let's do another one. Let's see what this one looks like. Okay. Here we need to find the vertex and the x-intercepts. So let's complete the square. So I need to bump that out of the way. Leave a space. What should I do next? Pull out the negative. Notice I did not take the negative out of the -7. Okay. What goes in the factor? -4, which means this is plus 16. So what did I really do by putting the 16 there? I subtracted 16. So to offset that, I need to add 16, and I get... So where is the vertex? The vertex would be 4, 9. Okay. How do I find the x-intercepts? I factor it. Okay. Well, when I factor, I don't like that negative. So what can I do to get rid of the negative? Divide everything by -1. Is that going to change the graph? Yes, it's going to flip the parabola upside down. But will it affect the roots? No. So this parabola looks like, so 4, 9, it looks like this. When I divide by -1, now it's going to look like that. But the roots aren't exactly the same place. What if I times it by -4? What would that graph look like? It would flip it and it would make it really tall. But the roots are going to be in the same place. So you can multiply by any number you want without changing the roots. It will obviously change the graph, but it will not affect the roots. So if I multiply by -1, I get x squared minus 8x plus 7. That factors into x minus 7 and x minus 1. So x is 7 and 1. Those are the x-intercepts. Okay. All right. So we would need to graph this one. Okay. So do you guys follow? Bump the 31 out of the way. Factor out the -2. So now we have -2 times x minus 4 squared, which means we add a 16 there. It's not really a 16. It's a -32. So I need to offset that -32 by adding 32. You confused? Huh? Oh, okay. So plus 32, which means I end up with +1. Everybody good? The vertex is 4, 1. And then normally I would go up 1 over 1, but we are multiplying by -2. So over 1, down 2. And then usually I do over 2, up 4. But we're multiplying by -2, so it'll be over 2, down 8. Right there. Oh, I missed. And then if you push that button, you'll get a quadratic. What if I push the button and I get this? It means that 2 of my points are wrong. You actually only need 3 points to graph a quadratic, but here it's asking for 5. But if you put one set of points in the wrong place and you get a W, you've obviously made a mistake. Okay, any questions about these? They're not too bad. Okay. A supply company manufactures copy machines. The unit cost in dollars is given by x squared minus 520x plus 73458. What is the minimum cost per unit? So we have a parabola, and that parabola tells us how much will it cost to make copy machines. Well, per machine. If we only make a few machines, it's going to cost us a lot, right? We have to buy the building, we have to pay for electricity, we have to pay taxes, and all of that stuff is really expensive. So making this many copy machines is going to cost us a lot because we had to put all that effort into the building. And then the more machines we make, the cost per unit comes down. But eventually there's a point where if we make lots of copy machines, then we have to pay overtime, we need to buy a new building, we have to have more taxes, we have a hard time finding parts. So if we try to make this many, the costs start going up. So there is a sweet spot in there. If we make just the right number of copy machines, then each copy machine will cost the minimum amount. So how are we going to find this number? We're going to switch it to vertex form. Okay. Can we factor? If we tried to factor, is it going to work? No. When I factor this, it will not factor. How do I know that? How can I guarantee it's not going to factor? Well, that would mean that the parabola crosses the x-axis, which would mean that the minimum cost per unit would be a negative number. So if a quadratic does not cross the x-axis, it won't factor. So that's not going to work. Okay. So x squared minus 520x, leave a space, plus 73458 So x minus, what would that be, 260? And then 260 squared is 67600. We're going to add that. Oh, it's a positive here, which means it needs to be a negative there. 73458. Okay, so my vertex is 260, 5858. It's a lot bigger than I would guess. So, what does this tell me? What does 260, 5858 tell me? Right. The best option would be if you make 260 copy machines, they will cost $5,858 per machine. If you make more machines than that, what's going to happen? The cost goes up. Why? Maybe it's hard to get that many materials. Maybe you have to pay overtime. Maybe you have to buy a new building. Don't know. But if we make fewer than 260, the cost also goes up. So to make the business as profitable as possible, you want to shoot for 260 machines. Okay. All right. So we have a graph and we have the equation of a function. And it says function 1, what's the vertex, and what's the vertex of function 2. So for function 2, you would move the 33 out of the way, and then you'd factor out the negative 2 and complete the square. Okay, which function has a larger maximum value? So you need to figure out where the vertex is for function 2, and then calculate which one is higher. And, oh, that's it. That's easy. Okay, let's go to this one. Domain and range. What is the domain? So we're going to draw a vertical line. We want to know which x's hit the graph. Does x equals 1 have a spot on the graph? Yeah, it's right here. Y equals negative 7. What about x equals 5? Does it have a spot on the graph? Yeah, it's 0. What about x equals 10? Yeah, it's way down here somewhere, but it does exist. So when I look at domain, I like to think of, oh, wrong button. If I take this vertical line and I move it around, will that line ever miss the graph? Is it going to hit over here? Yeah, it'll hit way down low. So the domain in this case would be all real numbers. And then for the range, we go the other way. If I draw a horizontal line, does that horizontal line ever miss the graph? Yes. So what describes the range in this case? Y is every number less than or equal to 1. So everything from 1 down on the y-axis has a spot on the graph. So you would just pick the right inequality. And how do I know it's equal to? Is there a point at 1? Yes. There's always a point unless it tells you otherwise. Okay. one more right here. How do we find the range? Well, for the range, we have to know, is this a happy parabola or a sad parabola? It's happy. How do you know? Because the leading coefficient is positive. So we're going to complete the square, and you'll get something like this. Right? And that will tell us the vertex. So let's say the graph looks like this. The range would be everything from 2 up. If the parabola was here, it would be everything from 3 up. So y is greater than or equal to 3. Whatever the y value of the vertex is, that tells you the range. Okay, any questions? All right, get to work.